Alrighty, welcome back to 105. Thank you for joining me again today. So today, we're talking about scope. We touched on it a little bit. It is not looking through, I don't know, a telescope or anything like that. It has different meanings. So also, just to make the terminology clear, when we use a function from main, we say we are calling a function or doing a function call. So what we did yesterday when we had, or not yesterday, on Monday, we had int main, void, and then we used our print triangle function we have created. We would say that main calls print triangle. So we start executing in main. Main is the location where we call that function from, so it calls print triangle. Then C would copy the arguments and essentially jump there and start executing that print triangle function until it is done. Then it will come back here or return where it left off, and it would return from main. So if we want to be specific, if we want to use the right terminology, we would say in this case main is the caller and print triangle is the callee. So every time you use a function, some function calls it, that's the caller, and then you're using a function that is technically called the callee once you get into compiler lingo. So return specifically that stops the callee and the caller resumes execution right where it left off. And the caller gets a copy of the return value as well. So the scope is the part of the program where you can use a variable in the simplest of terms. So you can use a variable declaration within the curly bracket you have declared it in until the next matching curly bracket ends it. So when C declares function arguments and for loop initializers, the only exception to that is they are valid in the next curly bracket, not the one before it, because, well, you're using the variables, defining variables in the for loop initializer or as function arguments. So, excuse the arrow is supposed to point up here and follow the execution. So I'll try and put the red marker where the yellow arrow is supposed to be. So variables exist within a function. We will learn more about this as we go on, but for now, just humor me. So on the right here, I have a green line here, green slash line with the name main. So these are going to be all the variables that exist in main. Initially, once we start executing our program, we start in main with exactly no variables defined. So this signifies the start of main, and any name variables I write above this line, they are defined in main. So we start execution, we don't do anything, and then we execute the line int I equals 42. In that case, there is a variable in main called I, and it has the value 42. And then I is valid here. I can use I as a name for the rest of this main function. So that's why if I do something like printf I and the value of I can use I as an argument to printf. I is valid there, and then I can return 0. That ends my program. So questions about that? That's where we are right now. All right, let's argue about it a bit more. So for loop creates something called an inner scope. So once we have curly brackets within curly brackets, that is an inner scope. So you can call it a nested scope, whatever you want to call it. So if we start execution here, again, initially at the bottom, main has no variables, no names are valid, nothing like that. So once we start executing this, we execute I is equal to 42. So then for the rest of the main function, I is valid. I has the value 42. Then we hit the for int j equals 0. Well, then j is valid here within the body of the for loop. And initially, j is equal to 0. Right? Then we would go through, print off j, in this case, is equal to 0. Then we would increment j. it would be 1, check if it's less than 1, it's false, so it's not, so it would fall out here, and then now I, or j, goes out of scope is how we would call it, where we're not allowed to use it anymore, it no longer exists. So right where the red cursor is, after the for loop, it is now done. If I tried to use it, I would get an error from my compiler saying again that j is not declared. So, questions about that? All right, the fun thing. You can quote unquote shadow a variable with the same name. So this is where we use a variable of the same name. So if we start our program again and I is equal to 42, and in our for loop we also use I, we're going to have a little bit of a issue or something might be surprising. So we started off, say int I equals 42, so main has a variable I, which is now equal to 42, and then we go into our for loop. So it also declares an I, so this is a new I, so whenever we see the type name and then a name, that declares a new I. So within the body of the loop, I would be valid here, which would maybe you think is I42, but you can essentially, if you have the same name in an inner scope, it overwrites that and you can't access the outer scope anymore. So within the for loop, now it would have its own I equal to 0 initially, and I is valid here. So the rule is if you have variables with the same names in different scopes, C will always use the most recent one or the newest one. So within the body of the for loop, it has a variable called I, and it is now equal to 0. Now I have no way to get this value of 42. I have no way to refer to main's I within the for loop. I can only refer to the for loop's I until that for loop is done. So again, it would print off I, in this case, equal to 0, plus I, so I would change to 1. 1 is not less than 1. Then it would exit the for loop, and at this line here, the I equal to 0. The for loop's I is now out of scope, so it doesn't exist anymore. So now if we used I after that, that would be, again, the I with the value equal to 42. So everyone okay with that? So probably a good idea just to name variables different names so you don't get surprised by that. So we can also just write a set of curly brackets wherever we want, and doesn't have to be associated with a function or for loop. That will just declare a new inner scope. So if we do this, so we write main int I equals 42 again at the top, and then just do curly brackets with int j equals 0, and we start executing this program. Again, after we execute this line, we create a variable in main called I equal to 42. I is valid until the end of this main function, so if I want to use I within this scope, perfectly fine. But j does not exist in this line, so the curly bracket just indicates some structure and the scoping rules. So nothing happens here, we don't execute that, we go into the scope, then execute j equals 0. So that would create a variable called j, it would be equal to 0, and it is valid until this ending curly bracket here. So I'm allowed to use j as long as I want until the end of it. And then at the end of it, j no longer exists anymore, and then I could hit return, finish my program. So questions about that? Typically, you wouldn't really do that, but you're allowed to. Okay, so going on to what we do care about. Functions create their own scope. So if I created this program, so this program just gets you to input 2 characters and then lists out which of the characters you have entered are digits. And this shows why we might use a function because, well, we have 2 things. I could write this program where I ask the user to input 2 characters like before, and then I individually, write this whole if statement for each character. But if you're repeating yourself, especially repeating complicated if statements, that probably means you're trying to convey some meaning from your code, and you should probably move that logic or all that work into a function so you don't have to repeat the work more than once. So doing this, my problem is I want to see if a character is a digit, so I can just write a character that takes as an input a character and returns a Boolean telling me whether or not it is a digit. So remembering the ASCII stuff before, this is how we would check that. We would make sure that the character is less or greater than or equal to 0 and less than or equal to the character 9. Again, because ASCII encoding is all in a row, so that would tell me whether or not it is a digit. Then we have is digit C1. If it is a digit, we'll print off that character. If C2 is a digit, we'll print off its character. So how this will work in terms of all of our variables is once we start executing this, we'll create C1 and C2, and they'll be valid for the rest of main. Because we didn't initialize them a value, I put a question mark there saying we do not know what their current value is. So that's, again, if we don't remember it from the beginning, if you don't assign it a variable or a value when you declare it, it just gets a random value that is undefined. So next lines, so C1 and C2 are valid for all of main. We execute, we ask the user to input 2 characters. Hopefully they're not a jerk. They actually input 2 characters. And then, whoops, so let's say they input the characters Y and 2 as part of the scanf. So remember scanf, we give it the address of these variables so that it can go ahead and change those values. So let's say I entered Y and then 2. So C1, the value of C1 is Y, the value of C2 is 2, the character 2. Then I printf digits, then I do the function call to isDigit with the argument C1. So again, remember C is copy by value. So this function call to isDigit is going to get a copy of the value of C1, and it will be copied into its scope or its variable, its input, whatever that name is, so it can actually use that value inside of its function. So in this case, we're doing it with C1, so the value of C1 is Y. So in isDigit, that would be a new scope. This is a new function call, so that's why I have this green line here with the isDigit function call. Gets a copy of C1, so its C is equal to Y. Everyone okay with that? Again, C is copy by value. We'll see why that's important in the next lecture too, maybe at the end of this lecture. So now within isDigit, only C is valid here. I can't use C1, I can't use C2. I can only use C as the input variable here. That is the only thing that exists. So I would do my checks, then return just a Boolean. So then it would either be true or false. In this case, it would be false. So isDigit would return false, and we'd get a copy of it as a result of this function call here. So this would get replaced by if false. So that would not execute. It would skip over here. Then if isDigit C2, so that is another function call to isDigit. So we're using it twice in this case. So in this case, since the argument now, we're giving it the input C2. Now this time when we call isDigit, it is another function call, but now the value is different, right? The value is now a copy of C2. So when we call isDigit this time, C is equal to the character 2. Again, copy by value. So isDigit will do its thing. Whoops, isDigit will do its thing. C is only valid there. The value of C this time is the character 2, which case, hopefully, it will be true. And then it would return the value true. Gets replaced here, so then that would be if true, which is, well, true. So we would print f that character. We can use C2 again because we've come back from that function. We're executing in main. We print off the character 2, then we have a new line, then we're done. So any questions about that? Good way to reuse our code. Yep?
So it returns true if C is between those two values, correct?
Yes. Yeah. So in this case, C the second time through is the character 2. So the character 2 is greater than or equal to the character 0, and it's also less than or equal to the character 9, so it's a digit. All right, any other questions about this? All righty, has anyone also noticed weird things about, has anyone had problems with scanf and characters and weird things happening? No? So, if I show you an example of, so let's go here. So here's that same program, but now with a slight bug. And I initialize a value of C1 and C2. That is not the problem. I'll give you this. So this could have weird, surprising behavior. I've introduced a bug to this. And isDigit still exists. It's unchanged from before. So can anyone tell me what is the issue with this? Although I'm not sure if they actually tested this in the test cases for lab 3, but they might have. So you might need to fix this if you have messed it up. All right. So let's make sure we compile it, and then we'll run isDigit. So if I input 2 characters, let's say 1 and 2, what should the output be? Anyone? Yeah. 1 and 2, right? They're both digits. 1 and 2. Everyone good with that? All right. What about if I do 1 and 2? What's the output? One and 2, right? Everyone agree? Yeah? There's a space, so it will be weird. How will it be weird? C1 and C2 will both be spaces, so nothing? Well, let's just see it. So do this, it says 1. So yeah, you're on the right track. Has to do with spaces. So all I did before is I deleted this space. So if I delete this, or if I add this space back in and have a space before the character, whoops, I have to compile it, of course. And it says input 2 characters, and I do space, 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 1, space, 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 2. If I put a space before that, C just ignores all of the spaces and then gives me the characters I care about, which is probably more what I expect. If I do not have a space before the character, for some reason, C is just like, well, in that case, if they type a space, I will capture a space. So that's why I have this little line here. So let's uncomment that. So now I have 2 characters without a space between them. So now if I compile and run this, and I do space, 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 whoops, those were B's. 1, space, 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 2, and hit enter, I get no output. And then here I print off, here just for debugging information, I print off the character and then the ASCII encoded value of the character in decimal. So here I see C1. Technically, it's a space. I just can't see it. 32 is the ASCII encoding number for a space. So here I captured 2 spaces when I had no spaces before it in the scanf format specifier. So If I don't have a space before it, it will just capture a space if a user inputs a space. So my rule for you is that if you do a %C format specifier, you want to capture a character, just always put a space before that. Otherwise, surprising things will happen. So now if I have a space before either of them, then it will eat up as many spaces as I type. So again, if I do space, 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 1, space, 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 2, then it will work like I expect it to. So don't ask me why C has these rules. They're silly. I had to even look them up. Once you get to writing more complicated programs, you will never use scanf. I've never used scanf outside of a first-year course. It's just easier to learn, I guess, but it has a whole bunch of esoteric rules that are very hard to remember and argue about. But one for you, if you capture a character, just put a space before the format specifier so bad things do not happen. And no matter what you do, oh yeah?
Is that only for the first character? So like, could you do space %C, and then?
Yeah, so that's the character. Is it only for the first character, or if I do this, is this okay?
Yeah.
So if I do that, from my rules, this will eat up spaces, and then this will match the first non-space character, and then this, since there's no space between it, would match it even if it is a space. So let's make sure I'm right. So space, 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 shouldn't matter. 1, space 2. So how I believe this will work is that, well, this format specifier, because I put a space before it, will just ignore all of this. The first format specifier matches this 1, and because there's no space after it, it would actually get this space as an actual character. So if I hit enter, I do see that I am right. So I need a space before every one, otherwise weird things will happen. And again, this, if you put a space before them, that doesn't require a space between them. So if I do, again, a space before either of them, compile that and just enter 1, 2, and then hit enter, still works, it's still fine, it doesn't cause any problems. It will just ignore 0 spaces if there's 0 spaces between them. So it's a much safer one to use. All right, any questions about that? Although I can't answer the why, that's just how it works. And whatever you do, do not do this. So do not put a space at the end. So if you put a space at the end, even weirder things will happen. Whoops. Apparently I can't spell compile. So here I did it. I put a space at the end. Now I hit space, 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 1, space, 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 2, hit enter, and it should work, right? So if you put a space at the end, it screws things up, and it waits for the first non-space character until it finishes the scanf call. So if I just do a bunch more spaces and hit enter, nothing will happen. Nothing will happen until I eventually hit a character, type a character and hit enter, in which case it won't actually read that, just wants some non-space character to read, and it just throws it out and bad things happen. So very, 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 very stupid rules. Do not put a space at the end of your scanf string. Otherwise, very bad things will happen. All right, everyone get my words of warning. Probably save you hours and hours and hours of debugging just in case. Because that was surprising to me. So surprising. I put on the slide, warning, beware, scanf behaves strangely with characters. So again, this is what I wrote, no space before the first format specifier. I entered space, in this case, capital A space D, then C1 is equal to space, C2 is equal to capital A. If I just do this, 2 characters, no spaces between them all, and I write space, space, A space B, then C1 is equal to space, C2 is equal to space. So unless you really want to capture a space character, which is probably not the case in this course, in bold here, always put a space before the C format specifier. And then I put in red and bold, just so you don't remember, never put a space after the format specifier. Otherwise, it will do something unexpected. Yeah?
If you put like the space before the %C, but the user doesn't type a space, does that
Yeah.
do anything?
Yeah, if you put the space before and the user doesn't type a space, it's fine. That doesn't matter. It will ignore 0 to as many spaces as you type. So it doesn't cause anything bad to happen. Just before C, always put a space before it. All right, and then yeah, from the real documentation for this, if you look at it, there's a quote from there. It says, "It is very difficult to use these functions correctly." So it's a good thing we're teaching them to you, right? All right, that was supposed to be funny. All right, so also just in case in terms of bad practice, again, that comma is technically an expression operator. So the comma operator will evaluate the expression on the left-hand side, throw the result away, then evaluate the right-hand side, and the result of the expression is the result of the right-hand side. So that means I can write insane things like this. So a for loop that declares two variables, int x equals 0, y equals 0, and then my condition is just x is less than y. And then I can put in here plus x comma minus y. So that will execute at the end of the body of the for loop every single time. And again, I don't use the value of this expression for anything, so it will just do both of these things. So it will increase the value of x by 1, decrease the value of y by 1 at the very end. So you might see things like that on the exam. Hopefully not. I try and tell them not to try and confuse you with commas and things like that, because they are a bit silly to put in there. And if you wrote that, that'd probably be bad style, and the TA would probably be also upset with you. But just in case, it is a perfectly valid thing to write in C, but just because it is valid does not mean you should use it. All right, let's have a little scoping quiz then. So I give you this program. So we have a function called swap at the top that takes an A and a B, and then inside this function creates a variable called temp, assigns the value of A to temp, then changes the value of A to be equal to B, then changes B to be equal to temp, which is what A was equal to, and then we print off swap whatever the value of A is, and then whatever the value of B is. And then in main, well, this is where a program starts executing, it has int A equals to 1, int B equals to 2. It prints off main before swap, the values of A and B. So again, they're in the proper order of their format specifiers. Then we call the swap function from main with A and B, and then we print off the value of A and B after swapping. So my question to you is, if I run this function, so let's go here. So if I run this function, what do I see printed? So I'll give you we got some time. I'll give you a minute to think about what we should see printed. All right, give you another 30 seconds here. Alrighty, time is up. Who can tell me what happens? Anyone? Yeah. Yeah, so first it'll print the values of A and B. What are the values of A and B? 1 and 2, okay, yep. Yeah, so then this swap, it would print A as 2 and then B as 1. And then at the end, it'll still print A as 1 and B as 2. Everyone got that? So let's run it and make sure. So what's this one called? Just swap. So if we run this, we see main before swap, A is equal to 1, B is equal to 2. Then in swap, A is equal to 2, B is equal to 1. And then after swap, A is equal to 1, B is equal to 2. So why is that? Again, copy by value. So in main, there's a variable called A and B. A is equal to 1, B is equal to 2. Printf, nothing confusing happens yet, so it should print off A is equal to 1, B is equal to 2. Shouldn't be a surprise to anyone. Then when we call swap A and B, everything just happens to be named the same, but they don't have to be. So when we call swap, the value of A and B from main get copied into the arguments here for this swap function. So A in swaps A is going to be equal to 1, swaps B is going to be equal to 2, but they are totally unrelated to mains A and B, other than initially they have the same values. So here, this creates a variable called temp in this swap function, assigns the value A to it, so the value 1, then assigns the value of A to be equal to the value of B, which is 2, then assigns the value of B to the value of temp, which is 1. And again, this is swaps A and B. So within this printf, this A and B refers to swaps A and B. So it would be 2 and then 1. Now this function returns nothing. So by default, if I wanted to, I could also write return with just a semicolon at the end to signify I'm returning nothing, that I'm at the end of the function. Just happens to be at the end of a void function, the compiler will automatically insert this for you. So this return at the end is totally optional. Most of the time you don't write that. So we would return back here, and now swaps A and B no longer exist. We get back to mains A and B, which are wholly unaffected by whatever happened in swap. So it would print A is equal to 1, B is equal to 2. Everyone get that? Okay, so we could swap things if we wanted to. So we can create something called a global variable. We kind of alluded to it before. And the rule of a global variable is it is always in scope, which means it's valid to use. Below its declaration, you can still shadow it and things like that, but you can use it if it's not shadowed. It's created before main actually runs, so it exists for as long as your program exists. So, disclaimer I have to put in here, they are not advised for this course, and you should avoid them. And if you absolutely have to make globals, whenever they're actually valid, you should declare them as static before that. All this means in this context is they can't accidentally be used in other C files, so that would be even more confusing than if you could only use global variables in the same C file you define them in. So static makes it so that you can only use that global variable in your C file, which is a bit better, and you'll get compiler warnings if you don't use that variable anymore. It's smart enough to figure that out. So I could modify my program to make my swap actually work if I do something like this. If I declare a global variable called A and a global variable called B that are initially equal to 1 and 2, so the value I set to them are going to be the value they get assigned when the program, before the program actually starts running. So because I'm using global variables, I can delete them here. The global variables a and b are accessible in this main function. And here, right now, if I'm calling swap with a and b, that would create a copy of the global variables in a and b. If I actually want to swap the values of the global variables, well, in my swap function, I can just make it so that it takes no inputs because I'm going to be operating on the global variables a and b. So if I do this, now this will swap the global variables a and b. So now my swap, I don't have to use any arguments. So now if I do this and I run my program, it will actually swap the values. So I should see main before swap, a is equal to 1, b is equal to 2, because those are my initial values whenever my program loaded. Then when I call swap, this temp variable only exists in the swap function. It assigns the global variable value a to it, which is 1, then changes the global variable a to be the value of the global variable b, which is 2, changes the value of the global variable b to 1. It would print swap, a is equal to 2, b is equal to 1. And now when I come back here, then the global variables still have the exact same value, right? They still exist. They don't exist. They exist as long as your program exists. So a is still equal to 2, and b is still equal to 1. So if I compile, run that, I should see that, yes, indeed, they did get swapped now. So questions about that? Yeah?
So, like, once we declare it as a global variable,
Mm-hmm.
I noticed that you removed, like, the int a and int b from the function since it's not necessary anymore. But what if you kept them there? Would the compiler get confused?
No, so yeah, that's a good question. So the question is, if I kept int a and int b here, and then I used a and b, would the compiler get confused? The answer to that is no. The compiler won't get confused. Whoops, that's not how you spell compile. So compiler, happy, no warning. But if I run this, what will happen? Yeah.
It'll be the same as the first time.
Yeah, it'll be the same as the first time, right? So the compiler doesn't care, it will let you do whatever, but it's going to be the same as the first time. Because what's going to happen now is that whenever I call swap a and b, again, C is copy by value. So this swap function is going to get a copy of the global variable a and a copy of the value of the global variable b. So the swap function would have its own a and b, which shadow the global variable a and b. It just happens to be assigned the same thing. So in here, this refers to swaps a and swaps b. And then it won't affect the global variable a and b. Yep.
For the global variables a and b, you're saying that if you don't declare them as static, you can access them in other files?
Yeah.
Really?
Yes.
Is it the same thing for Java?
Yeah, so the question is, so goes beyond a bit the course. So if I don't access them like this, if I don't do it like this, you can technically access A and B in other files. You wouldn't have to know how to do it. We don't write programs that are big enough to need 2C files, but you can do it. And it's even more confusing and even more of a bad idea. So you should just do this. And I think the rules of Java are the same, except it doesn't have C files, but same idea. All right, everyone good with that confusing bit? Basically, don't use global variables. So that's covering all the functions you should also practice. So again, I've said it before, but just so it's on the slide, we are now completed up to chapter 5 of that Learning C online book. Again, it's created by the course coordinator, has examples from the lectures or from the exams and everything like that. So there's the link to the chapter 5 exercises, should be able to do them. Again, you also have the past exams. You can ask on Discord and everything like that. So to motivate the next one, we will write a real swap function. So remember, in order to have scanf change the value of the variable I give it, what did I have to use? Yeah, the ampersand, right? And then that meant that scanf function could actually change the value. So it kind of looks like I'm not giving it a copy of my value. I'm allowing it to change it, which is why we have to use the ampersand. But this will motivate our next topic. So if I wanted to correctly write the swap function, well, we have to learn the details of that ampersand operator. So if I want to actually correctly write the swap operator without, or the swap function without creating global variables, I have to essentially do what scanf does and take the variables with that address of, or that ampersand operator. So I have to write swap like this. So in main, I declare A and a B, and then I print off again the values of A and B before swap. Now, this will be slightly confusing, but we will explain it in the next lecture. So I give the address of A and the address of B. So remember, that essentially tells you where in memory the value's actually stored, right? Because memory just looks like a whole bunch of bytes, and the address is just the location where the byte is actually in memory. So that would tell us where that byte, or where that value is in memory. So the type of the ampersand operator is that int with the star. So what that means is, again, this will be the next lecture, but that's basically saying that instead of getting a copy of the value, I am pointing to that value. So I'm keeping track of where that value is in memory, and then I'm going to modify where that value is in memory instead of trying to modify that value itself. So that's basically what int star means. It means pointing to that value. Yep.
So for the midterm, like will the functions that we write be passed by value, or would there also be some passed by reference?
So C does not have pass by reference. It's only passed by value. So in this case, the value I'm passing to it is a pointer, but still by value. So there's really no pass by reference, but this kind of looks like pass by reference, but really it's passed by value. Yeah.
So we could ask a question from Discord. How do we get access to this Discord?
Oh, on the compeng.gg site, if you go to settings and connect your Discord, it'll join you. Yeah, yeah. Yeah, if you're not on that Discord server. I think there's like about 100 people there right now. It's not terribly active, but I have been answering questions there. So these little pointer operations are a bit weird. If I want to get the value at A, what I have to do is something called dereferencing. So I have to do star A, and that will get me the current value that is pointed to by the this A pointer type. So this would be the value pointed to by, in this case, the argument A here, which is a pointer. So that would give me the value 1. Then I assign it to temp. Then this would change the value of A to the value of B. So this would change A to be equal to 2. Then change the value of that's pointed to by that B argument to be equal to temp. And now that allows me essentially a roundabout way to get access to these values, to main's values of A and B in the swap function. So when I actually run this and do swap real, it does actually swap the values. So that is the magic of pointers, and that will be our next topic. I will explain it in a lot more detail than that. But this is just to get you warmed up to the idea and the magic of pointers, because they are a bit strange. So with that, we can end 5 minutes early. Everyone loves that. So just remember, pulling for you, we're all in this together.